Topic is mathematical reasoning. Mathematical reasoning. First thing that we have to understand, what is a statement? What do you know? What is a statement means? And what does sentence means? A sentence basically means a group of words or a group of just some words. Sentence, it can be anything. But a sentence, say what is a statement mathematically? A sentence which is either true or false, true or false, but cannot be both. Both are called
How can a sentence be true and false?
True or false.
No, but cannot be both means isn't it a given? How can a sentence be true and false?
I'm explaining, just wait a second. Both are called a statement. If we are talking a sentence which has only probability of being either true or either false, it cannot be both. I will give you example what is both the situation means. Sentence, if I am saying earth is round, so it is clear. My sentence is clear. It is either true or it is false. Okay, there is no doubt in it. Fine, there is no doubt in it. So that is a true statement. Okay, got it? A sentence is either true or false, but cannot be both. Are called a statement. So we have only two options for a sentence. If I'm speaking any sentence, it will be a statement if we have only two options, either it will be true, either it will be false. If we can clarify it, yes, it is true or it is false, so that type of sentence is called statement. Fine, I will give you some examples now. A few more things. A sentence which is exclamation sign, or a wish, like good luck, a wish, maybe a wish, or an interrogative sentence.
That means a question.
Yeah, question, requesting, interrogative can not be a sentence. Cannot be a sentence.
Statement or sentence?
It cannot be a statement. Like if I ask you a question, where are you going? So you may answer it correct or you may answer it wrong. Okay, so that is not a, if I request you, please give me a glass of water. So you can give me or you cannot give me. So that is not a, so these all exclamation sign, hooray, like winning a match or something, exclamation or a wish, may God bless you. So this is wish. Interrogative, if I'm asking something. So all these are not a statement. All these are not a statement. If something is there, it's not a statement. Now, if a statement is true, then truth value is T. And if it's a false statement, its value is F. Its value is F. If it's a truth value. So if it's a correct statement, so that is truth value will be T. And if it's a false statement, so it's truth value. Truth value is 10. Now see few examples I will tell you. Note it down till here.
But a statement, it depends on how we perceive it. No, it can either be true, it can also be false.
No. There are some rules, what I'm telling you. If you perceive exclamatory is a statement, it will not be a statement. If you perceive wishing is a statement, it's not a statement. If you perceive like interrogative is a statement, it's not a. This rules you have to follow. And I'm giving you some examples.
Yeah, I wrote this.
Let's take few examples. Like if I say, so New Delhi is capital of India. Is capital of India. So it is yes, right. It's a true. It's a statement. Okay. And its truth value. It's a statement. It's a statement, and the truth value is T. Truth value is T. Now, second example, if I say 3 plus 2 equals to 6, so it's a statement.
Statement, but truth value is F.
Yeah, the truth value is F.
Statement doesn't need to be in words, it can be anything.
Yeah, anything. Now, the third example, if I ask you, where are you going? It's a interrogative. So it is not a statement. Not a statement. So what is the rule now we got? A statement.
For this, truth value is what?
Truth value is this. It's not a statement, so no truth value for this. Only the truth value is defined for the statement. So if it's not a statement, no truth value. So a statement cannot be true or false at a time. Okay, got it? This is the concept. It can either be true or it can either be false, nothing else. Now, next thing is paradox. Paradox. Paradox is a sentence which is both true and false at the same time. I will give you an example. See, a sentence which is both true and false at the same time. At the same time.
Now this depends on like people's opinions.
Yeah, I will tell you example is called a paradox. Paradox. Like example is that. Like first example is no one goes to restaurant because it's too crowded. See, this is a paradox. No one goes to restaurant because it is too crowded. If no one goes, to how crowd came from? Okay, it's a paradox. So no one goes to restaurant because it's too crowded. So if no one is going, so how it is getting crowded? So that's the paradox. Okay.
Yeah.
Now, next example we can say like nobody goes near water until he or she has learned swimming. So this is also a paradox.
Yeah.
How without going near to the water will learn swimming? You have to go to water for learning swimming. So this is called a paradox. So this is not a statement.
Paradox always starts with no one, nobody, like that.
Yes, you can see that it's yeah. Now, one question. Not right against. If I give you a question like the sum of x and y is greater than 0. The sum of x and y is greater than 0. So it is a statement or a sentence?
Statement.
No, it's not defined. We don't know what is x and y. So how can I say it is greater than 0?
No, but it's still a statement. The truth value can be T or F, no?
No. If I say the sum of x and y is greater than 0. So how can I say that it should be greater than 0? How can I say it's greater than 0? If I'm saying that the sum of x and y is greater than 0, so it is not a complete statement. I am not knowing x and y. So how can I claim that it is going to be greater than 0? So it's not a statement. Understand?
Okay.
Yeah. So if I say the same thing, the sum of x and y is greater than 0. So I am not knowing what is x and y. So how can I claim it is going to be greater than 0? So it is not
But
a...
that is the job of the truth value, no?
No. First, we have to decide a statement. If it's a statement, then only the truth value exists. First, the truth value exists only for the statement. So before going to the truth value, we have to see that if it's a statement or a sentence. So it's not a statement. It's not a statement. It's not a statement. Now, if I say the square of a number is even, the square of a number is even. So it is not a statement. The square of number is not sure to be even only. It can be, it's not sure which number I'm talking about.
It can be even or not.
Yeah.
Like 9 square is 81. That's odd.
Yes, that's fine. Now, if I say 3 plus 4 equals to 6.
That statement, but truth value is false.
Yeah, right. That's a statement. Yes. Okay.
But what I don't understand is like this X and Y, right? No matter what it is, even if it's not greater than 0, won't it still be a statement and truth value can be false?
If I say that the sum of x and y is greater than 0. Okay. Leave the truth value thing first. Is it a statement?
It can be.
No, it is a no. It can or cannot. There is no option. That it's not a paradox. It can or cannot be the paradox thing. So you have to be very clear. If it's a statement or not. If it is giving you meaning or not. If I say the sum of two numbers.
It has to be like clearly defined for it to be a statement.
Yeah, that's what I'm saying. It has to be clearly defined that you can just say yes or no. So if I say the sum of two numbers is x and y is greater than 0, so you are in doubt. If I take x and y negative, then it will be not 0. Then it will be less than 0. If I take x and y positive, so it will be greater than 0. So you are in something doubt in that. You are not clear about it. Now let's say if I say every square is a rectangle. Yes. Every square is a rectangle. Yes. Yes, it's true. The truth value is true. It's a statement. Its truth value is true. If I say, please do me a favor.
That's not a statement.
Yeah, that's not a, because I'm requesting, interrogating, or asking or wishing is not a statement. Okay. That's statement done, paradox done. Now, next is compound statement. Compound statement. Compound. A statement which is made up of two or more statements. Two or more statements is called a compound statement. It's called a compound statement. Two or more statements. And one more thing. An example I can give you. Like 2 is prime. 2 is prime, or it is even. It is even. Or it is. Now, this statement is made up of two things. One is 2 is prime and it is even. And then we have a
Or
that joins this. Okay. So how we write it? Like we write P is a part of the component of this statement.
or means it can either be this or this. No, do we have to like choose?
Yeah, it can be either of this. Yeah. So it is, you will write 2 is prime, 1 cent part of it, and Q is 2 is even. And this is called logical connectors with join two statements. This is called logical connectors.
Okay.
So compound statement here.
But again, isn't this like it can be prime or it can be even? So there's not like a definite answer, no? So isn't it like paradox?
It's not a paradox. It is the two statements which are joined together. This is a statement and this is a statement. Two different statements are joined by this.
Okay. But just like using or to join it basically means like it can be this, it can be that.
No, in mathematical reasoning, we are going to use 2 or 3 like logical connectors. We have to read that. And or you must have in grade 12. Have you done the semiconductors? No.
In physics.
Yeah, there is something. Okay.
And or not like
Yeah,
that.
and or not gates.
I did that in computer last year.
Yeah.
Computer
Yes. And or not gates. So this is a logical connector. We are joining the two statements. Now, if I say, example we are taking, all prime numbers are either even or odd. So we have to decide, see this, the both components are true or false. So one component is here.
True. Both are true.
All prime numbers are even one component, and all prime numbers are odd one component. No, that is wrong. Both of them are wrong. How can I say all prime numbers are even?
Oh, okay.
So it's a false statement, and even this is also false. So both are false. Both the statements are false. All prime numbers are even. We cannot say that. It's a false statement. And next, all prime numbers are odd. This is also a false statement.
But when you say the whole sentence together, it's true, no? All prime numbers are either even or they're odd.
Whole sentence is fine. I'm just asking about the components. Okay, done. Now, next we have truth table. You must have done truth table.
Yeah.
This is an easy and a scoring chapter, but this is not in NCERT book, so most of the students just ignore this chapter. Now, truth table. A table which shows the relationship between the truth value of compound statements.
I have a question. Over here
Yeah.
in compound statement, can one component have truth value true, one component can have
Yeah.
false like that?
Yes.
Okay.
Compound statement. Truth value of compound statement and the truth value of its substatements, a part substatements is called truth table. It's called truth table. That shows basic relationship. Let's take an example slide. Okay. Truth value for single statement P. Single statement P. So number of rows will be how much? Number of rows will be if P only one statement. So it can be either true, it can be either false. That's a truth table. If we have a single statement P, so it can be either true, it can be either false. So the number of row is going to be 2 only. Okay.
Okay.
Now, if I take truth value for two statements, P and Q. So how many number of rows? So number of rows will be 2 square. Because 2 components, so 2 square 4. Why? See, you have 2 statements, P and Q. So P can be true. P and Q can be both true. Okay, they can be true, false. They can be false, true. They can be true. Okay, 4 conditions.
We're not counting the heading as row, right?
We are counting the rows. Row 1, the conditions. We're counting just the condition. P and Q with the heading, like P event and Q event. Okay.
Okay.
Now, third condition. Truth
So truth value for n number of statements will be 2
for
raised to n.
3 statements will be 2 raised to the power 3. And for n statements, 2 raised to the power 2 raised to the power n rows. Okay, done.
Yeah.
Now, next is logical connectors. Logical connectors. The same thing or and not this all thing. The words or phrases which combine the words or phrases which combine simple statements, simple statements to form a compound statement. Compound statement. The word phrase which combines statements are called logical connectors. Or connectives also we say sometimes, logical connectives. Connectives. Done?
Yeah.
Now operations, the name of operations are, this is called conjunction. 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 Then this we have disjunction. This we can say implication. Implied that implication, or we say conditional. Conditional. This is called equivalence. Equivalence or biconditional. Equivalence or biconditional. Equivalence or biconditional. Okay. Now see how you can keep in mind the symbols. Like and is like A and D. Fine. A and D. So this is like A and D. A. Fine. And A and D. Or is just opposite of it. And if and then this symbol. If and only if both sides. Okay. So to use that, like this is and symbol. This is or symbol, and is called conjunction. This is called disjunction. This is called implication or conditional. This is equivalence, or we say biconditional. Okay, got it?
Yeah.
Noted?
Yeah.
So you must be knowing the rule for and, na?
Rule for and?
The truth table for and. See, I will tell you. The connective and. What happens there? Any two statements can be connected. Any two statements can be connected by the word.
Both should be true or both should be false, like that?
Both should be. I will tell you. Easy way. Try the statement. In any two statements can be connected by the word and to form a compound statement. That forms compound statement. To form a compound statement. With word and is true. Is true if all its components component statements are true. It can be only true if both the statements are true. And all the cases, and all other cases, it will be a false. And it is shown by P and Q. This is how it is shown. P and Q. So it is only true if both the statements are true.
And false if both the statements are false.
All condition it is false. So
a compound statement can be more than two statements also, no?
Yeah, actually. Yeah. But mostly we have to deal with two statements. This is P, this is Q. And then we have to do P and Q. Let both the conditions be true. So it will be true. If one condition true and false, so it will be false. So it is only true if both the conditions are true. Let's say it is false and then true, so again false. If it is false and this is also false, so again false. Only true if both the conditions are true. So P and Q is true only when both P and Q is true. Both P and Q is true. Both P and Q is true.
Yeah, done, sir.
Okay. So this table also done. The connective or we will not try to all statement. What we can do, we can make a table on this. Like if it is P, this is Q, and this one is P or Q. So let's say both is true, or so this will be true. If it is true, it is false, so again true. If it is false, it is true, so again true. But if both are false, then only it is false. So every condition, only false condition is that if both are false.
So when either of the condition is true, it becomes
It
true.
becomes true. So P or Q is true if at least one of P and Q. Or at least one is true, so it will be true. And in or and it was, both should be true. Then only it will be true. So and or we have done. Now few questions I can show you. Question is like, find the truth value. Find the truth value of following compound statement. Compound statement. Like let's take first example. 3 is an odd number. 3 is an odd number, or 4 is prime number. Prime number. Decide the truth value.
True.
True.
Yeah.
This is our P.
P is true and
And
Q is false, but it's odd, so it becomes true.
This is true and this is false. So this will result into true. Now, the next one. All living things have 2 legs or 2 eyes. All living things have 2 legs or 2 eyes. So this is P and this one is Q, or P or Q. P is false.
Yeah.
Q is also false. It is or.
False.
Done. Now, one more example. 2 divide 4 or 3 multiplied by 4 equals to 12. 2 divide 4. So it is P. This is Q and this is R. This is true and this is true. So that is true. Sorry, let me one more. All natural numbers are even or odd. All natural numbers are even. That is
This
Q.
is
All
false.
natural numbers are odd. This is Q and this is R. So both the conditions are false. It falls. Okay.
Yeah.
Now, next. Now we'll write the topic. Types of one is exclusive or exclusive. If in a statement P or Q statement P or Q happening of any one P or Q excludes the happening of other then it is exclusive or. So that means that here both P and Q cannot occur together. P and Q cannot occur together. Like if you're tossing a coin. So head and tail cannot come together. Okay. So either you will get head, either you will get tail. They cannot come together. So one example we can take. I will go to Delhi. Either by bus or train. So I cannot do both the work simultaneously. So it is an exclusive one. If I go by train, I cannot travel by bus. If I go by bus, I cannot travel by train.
Yeah.
Okay. This is called or exclusive. The happening of one restricts the happening of other. If one has happened, other can't happen. Happening of one restricts the happening of other. That is.
But still here the truth value will be true, no?
Truth value will be.
Will it be true?
Yeah, it will be true only. Truth value. Now, exclusive or we have the next is inclusive. Inclusive or. If in statement P or Q both can occur together. Both can occur together. Together, it is inclusive. It is inclusive of. Example. Inclusive of. You can have burger or pizza. Both you can have, no problem. Okay.
Mm.
This is inclusive statement. Or is there, but you can have both conditions. Both you can have. Done?
Yeah.
No. Mm. Now this is P or Q. Hmm?
Mm.
P or Q. We had two conditions. One was inclusive or, and one is exclusive or. So inclusive or in both P and Q can occur together. Can occur together. If both P and Q cannot occur together. Done?
Yeah.
Let's take few examples and let's see. A number is either rational or irrational. What is this?
This is exclusive or.
Exclusive. Exclusive or. Because if I say a number, any number like 2, it cannot be both. It is rational only. It cannot be rational. It's crystal clear like this. It cannot be both situation. If I say root 2, so it is irrational.
Yeah.
Now, next example. The office is closed if it's a holiday or Sunday. Holidays.
Inclusive or, right?
Yeah, inclusive it is. It may be, let's say, any like Christmas. Christmas is falling on Sunday. So Christmas is a holiday and Sunday is there. So it can be inclusive. Both can occur together. Holiday and Sunday can come together. It is inclusive. Understand?
Yeah.
Now, let's take one more example. Like sum of two integers is odd or even.
It's exclusive or.
Yeah, it cannot be two like same. Either it will be an odd or either it will be even. It cannot. So it is an exclusive. exclusive of. Done. Got it? Children?
Yeah.
So we have done two connectors, and or. We are done with that. Two more is there.
Not is not a connector.
Which one?
Not is not a connector. What is not?
Not I'm teaching right now. Not in this. That is a different topic. Negation of a statement. Negation of a statement. Just converting it to negative. Negation of a statement. The denial of a statement. Statement P. The denial of the statement P is called its negation. Its negation. Written as negation of P. Negation. And read as not read as. So the truth table for the negation is going to be this is P and this is negation of P. Negation of P. If it is true, so that will be false. If it's a false, so that will be true. Done. Done.
Yeah, done.
So P and Q is similar to intersection. Intersection. This is intersection symbol. And P or Q is similar to union. Similar to union. And negation of P is similar to complement. Now, next two connectors will continue in the next session.
Okay.